Alright, so carbon bonding involves involves carbon atoms, right? And we're going to talk about what resonance means. So, remember, carbon has some unique properties to it. When we do compounds with carbon, carbon is always going to be the central atom. So that means carbon is always going to be in the middle. So if I have CH4, like we saw before, carbon is going to be in the middle. Let me not put that yet. So when we do it, carbon will always be in the middle. Hydrogen here, hydrogen here. So it's in the middle, not so? It can also undergo bonding to itself. That means you can have a carbon bonded to a carbon. That's called, when it can bond to itself, that's called catenation, because it can form long chains. We'll talk about that later on. Now, carbon always has 4 bonds around it. It's always going to have 4 bonds around it. So here we see, if we were to put bonds, that means we need to put 1 here, 1 here, 1 here, and 1 here. Alright, let's look at examples. So here now, what we just said, carbon is always going to be the central atom. So how many carbon atoms do we have? 2. Carbon and carbon. We put carbon and carbon. How many hydrogens do we have? 6. So we're going to change, let me change this color. And then change. Okay, so we're going to write our hydrogens are on each carbon, right? So I'm going to write 1 here, 1 here, 1 here. That's 3. No, can I add 1 more here?
Where?
Can I add 1 more here?
No.
No, I have to go around the other carbon now. So put hydrogen here, hydrogen here, hydrogen here. Okay, now let's do how much. Let's do our needed, available, shared, all those things. How many are needed? 2 carbons, each carbon needing 8, plus 6 hydrogens, each one needing 2. So that gives us a total of what? 28. How many are available? 14. Good. How many are shared? 14. How many bonds? 7. So let's see if that is actually true. Okay, so let's put in our bonds. 1 between the carbons, not so, because they can be bonded to themselves. 2, 3, 4, 5, 6, 7. Now count. How many electrons are on each hydrogen? 2, 4, 2, 2, 2, 2, 2. Each carbon, 2, 4, 6, 8. 2, 4, 6, 8. Now, didn't we say that each carbon needs to have how many bonds around it? 4. 1, 2, 3, 4. Agreed? 1, 2, 3, 4. Now, look at the number needed and the number available. What do you realize? It is half. The number available is always going to be half. So whenever you have a compound that is carbon and hydrogen only, the number available will always be half the amount needed. Here, how many carbon atoms do we have? 3. So I'll be right. If I would write 1, 2, 3. Okay? Let's do, how many hydrogens do we have?
8.
Alright, 8. So that means you write 1, 2, 3, 4, 5, 6, 7, 8. Agreed? Alright, if we do needed, 8 times 3 is 24 plus 8 twos are 16. 24 plus 16 gives us
40.
40. How many are available?
4 times 3.
4 threes are 12 plus 8 is? Needed and available. The amount available is half the amount needed. So how many will be shared? How many bonds?
10.
Alright, so bonds will be 10. Let's draw in our bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how many bonds do we have around each carbon?
4.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So are we good?
Yes.
So we're done. So do we really need to do needed and available with carbon in this case? No. Good. Okay, let's look at this one. How many carbon atoms do we have? 2. So that goes in the middle. How many hydrogens do we have?
2.
So the most symmetrical is to put 1 on each carbon, not so? Doesn't make sense putting both of them on one carbon because it's not symmetrical. So let's do our needed. Each carbon needs how many? 8. Each hydrogen needs 2. Alright, 8 twos are 16 plus 4 is 20. Let's do our available.
10.
How many? 10. How many shared will be?
10.
Bonds will be
5.
5. So let's put in our bonds now. 1, 2, 3.
4, 5. On the outsides.
Can I put, so that means we need 2 more bonds, right? No, can I put a bond here? No, because hydrogen only needs how many bonds? 1. Hydrogen only needs 1 bond.
Triple the inside.
We do what on the inside? Excellent. Excellent. We need to triple. I'll put them in different color. So that's the second one. And then we write the third one. Now, count around each carbon. How many bonds do we have? 1, 2, 3, 4. 1, 2, 3. All right. So we're good. Not so? Each carbon has 4 bonds around it. Each hydrogen is good, so we're good. Simple enough. All right. Count. If we count our bonds, we have 1, 2, 3, 4, 5. Electrons used 2, 4, 6, 8, 10. How many did we have available? 10. So we talk about bond length and bond strength. Now, bond length is just the average distance between the nuclei of 2 bonded atoms. That is how far are the nuclei from each other. That's what we're looking at. Now, more bonds we have, the shorter the bond length. Think about it. If you have more bonds, there's going to be more pulling, not so? More pulling, closer the 2 atoms will be. The 2 nuclei will be. So, single bonds, they're going to have the longest bond length. And triple bonds will have the shortest bond length. More bonds, the stronger the bond. So, triple bonds will be the strongest, and this will be the, if I can spell weakest. Okay? So if we look at that, the strength increases this way, right? And the length increases this way. Agreed? All right, now let's look at a table. And if you look at the table here, doesn't it show that same thing? All right, so if you look at the bond length for single bond, double bond, triple bond, long to short. Look at the bond strength, weak to strong. Does that make sense to you now? Okay, and that's what we need to know about that.
That's it?
Yeah, that's what we need to know about bond strength and bond length. Okay, now what does the P here mean? Picometers, very good. So the P means picometers. So the bond length is measured in picometers, and bond strength is measured in kilojoules. Good. Okay, when we talk about resonance structures, we're talking about Lewis structures that differ in the position of their electrons. Now, the double bond can be placed in multiple positions. Remember we were talking about those earlier on? So like when we did the carbonate, and we're going to look at another example, we were asking where should we put the double bond? Okay? So these are examples of where they can be different. So we're going to look at these examples now and see exactly where we can put them. If you look back on your notes, you see that we did this one already. Okay? But let's still, you want to do our needed, available, shared, bonds, just to keep you going through the process of thinking about it. Okay? Right? We know which one's going to be in the middle. Carbon is going to be in the middle with 3 oxygens around it, right? Good. Let's put our parentheses, because we know it's an ion. Good? Now, how many are needed? If you just go back to it, go. All right, so we need how much? How many? 32. Yeah, how many are available? We said 22 plus 2, which is 24. We know we have 8 shared. How many bonds we have? 4. So here's what we do. 1, 2, 3. And then we get to the point where, oh, we need to double one. So we double that one. If we double that one first. No, then we add what next? The lone pairs of electrons. We add how many here? 2 to this one, and then 3 to the rest. Then you may think, ooh, I'm done. No, you're not done at this point. You just started. Didn't we say that the double bond can be placed in multiple positions? So we can draw 2 more structures for the same compound.
So we have to put all the possible.
Yes, if I ask you for resonance structures, you have to put all the possible ones. So let's see. Carbon in the middle. Oxygen, oxygen, oxygen. So what we're going to do in this case now, we're going to move the double bond. Okay? So we put 1 bond here, 1 bond here. Let's put two bonds here. Not so?
Yeah.
Then we do our same thing with our lone pairs. 2 here. Sorry, this is one is going to be 3. 3 here, right? Make sure I get it in. And then 2 here. Okay, and this goes in parentheses. And that's our charge of negative 2. All right. Sorry, hold on. This shouldn't be here. This will be on the outside of it. As soon as it allows me to write, yeah, this is here. So that tells me, so far, what is that telling me? That this could either be this or this. And we're not done. There's one more still. So this one, it can also go, so we can put a double bond here. So you see in all 3 structures, what we've done is that we've changed the position of the double bond. Now it's still the same thing, but what's changed is the position of our double bond. Now, when we look at that, how many different bonds do we have here? How many different bonds do we have? So we have 3 bonds, right? We have 3. We have 2 singles and a double. But we have how many different bonds? 2 different bonds. We have 2 singles and a double, so we have 2 different types of bonds. So you would expect how many different bonds there? But when we look at it, we'd expect either to be single bond or double bond when we look at bond lengths, not so? But when we actually look at the bond lengths, what we find, it's an average. It's somewhere between the length for 2 bonds and somewhere between the length for a single bond and a double bond. So that tells us this structure is neither this, neither this, neither that. It is a combination of these 3. So that means if I pull a carbonate ion, and let's suppose we were able to just look at their structures, you'll see some like this, some like this, some like this. Just like we talked about isotopes. Different form of the same compound, same element. Not so? Same thing here. Different structures for the same compound. That's what resonance structures mean. You have different structures for the same compound. Okay, NO3 minus. How many are needed? 8 times 4 is 32. How many are available? Nitrogen has how many? 5. Oxygen has 6. 6 3s are 18 plus 5 is 23 plus 1 is. Everybody remember how we got the 1, right?
Yes.
Good. How many will be shared? 8. How many bonds? So which one goes in the middle? Nitrogen is in the middle. Oxygen, most symmetrical form. How many bonds? 1, 2, 3. And then we realize what? We need another one. So we can put 1 with the bond here. How about we draw another one? Put a double bond here. Wrong color here. Good? Can we do that? Or can we do all these are possible, not so? But what do we have to add now? Our parentheses to each one. And the charge and something else. So all these will be negative, negative, and then we need to add our what? Lone pairs, not so? 2 here, sorry, 3 here. And we only have 2 on this one, not so? Here we add the 3 lone pairs are 6 electrons. Here I'm going to add 2 because this one has a double bond. Here I'm going to add 3 lone pairs because it doesn't have the double bond. 3 lone pairs here. 2 lone pairs here. And 3 lone pairs here. So what we've seen here is that when we have double bonds, the double bonds can be placed in multiple positions. So no one structure is correct. Now if I ask you simply to draw the Lewis structure, then you can choose any one of these. Okay, but if I ask you to draw the resonance structures, then you need to draw all 3. Okay?